Hello guys, welcome back. It's Dr. Anjit here. So I just wanted to give it a trial on how to discuss skin histology. So I had two options. One to have a slide in the background, which has some technical problems here, and second one is to put a PPT and show you screenshots of the histology. Right? Do let me know whichever you like. And now I'm going to start with a very simple, basic video, maybe a kind of 5 or 10 minutes. I wanted to split in bits and pieces, and like I said, we'll be trying to cover the entire histology for pathologists, right? So I'm sure you can see that here is a classical stratified squamous epithelium or the skin lesion, right? So this is a normal skin. We are going to read the normal histology of skin layer by layer and every important detail required for the pathologist to extrapolate to multiple diseases, fine? So it's multi-layered, obviously. You can see, look at that, look at the beauty of the skin, right? So I'm sure you must have known the basal layer, this part, you can see that it's palisaded. It's definitely parallel to each other, and also this part here on the top here is the dermis, right? You can see the dermis and you can see the cells here which are perfectly parallel to each other, right? That's your palisaded basal epithelium, right? So the basal epithelium has one important guy, and if you can look at the basal epithelium, almost everyone has on the top the black brown pigment, melanin. Those are not melanophages. Please be very, very clear. All those are nothing but basal keratinocytes. They are squamous epithelium only, but they also will have melanin. So what happens is when a melanocyte, which comes from the neural crest derivative, comes to the epidermis, it stays here, right? This person here is a melanocyte. You can see a person with a halo around. You have nucleus and there's a clear halo around. That's a melanocyte. So what melanocyte does is they produce or they synthesize melanin, and they don't have the melanin. That's why most of the time melanocytes in melanocyte looks. Maybe if you go here, can you look at this melanocyte, right? So melanocyte generally might not have dense pigments, but melanocyte will have like a dendritic cell network. It will send the pigments onto all of the epidermal cells, right? Not just your basal layer. If you can look here, can you see this here also has your melanocytes, right? Melanin. The beauty of skin is such that melanin is actually an UV protector. Right? You can see here you have the keratin layer here, so the light is going to come via this, right? So what happens is when a light comes and hits my skin has to protect it because UV rays are supposed to cause mutation. So it's like melanin is on the top. It's like a cap, right? So the melanin is here. UV rays comes from here and it protects my keratinocytes from undergoing mutation, right? So melanophages are not the one which are brown in color in a skin biopsy. They are all keratinocytes. The melanocytes, like I said, it'll have this clear halo around, right? It'll have a clear halo around. That's the characteristic appearing of a melanocyte. Look at this. That's a melanocyte. You can see that it is said that every 10, 15 of keratinocytes will have a melanocyte in center. And just scrolling through it, can you see that every 10, 15 of the basal epithelium, you have a cell with a clear halo? It's very classical, isn't it, right? Look at this guy. Look at this. I have a cell with a clear halo. Maybe one more here. And if I go here, there's one on the back of my head here, right? One more here, right? Those are all the melanocytes. Please be very, very careful. Understand this. Melanocytes will not be pigmented in an epidermal layer. It's going to be the keratinocytes will be pigmented, which acquire the melanin from melanocytes, right? That's with the basal layer of epidermis. Then when you go a little bit to the top, maybe I'll go to this area because it's a bit more thicker, right? So here you have lots of cells here. I cannot zoom beyond this. All these are your stratum spinosum. The entire thing here is stratum spinosum. And obviously here, can you look at this guy? You can see the granules here, obviously. This is my stratum granulosum, right? The keratohyalin granules. I'll come to the keratohyalin granules soon. It's not so complete here, right? We'll go to stratum spinosum here. Stratum spinosum is also called as a prickle cell layer because they have the your desmosomes, the hemidesmosomes, which connects with the other guys, right? Or the intercellular bridges. Because the intercellular bridges, it looks like projection all around. That's a prickle cell layer. That's how a keratinocyte looks. There's a keratinocyte with all the connections around. That's a classical prickle cell layer, right? Okay, that's your stratum spinosum in general, right? In skin, when you have skin of palms and soles, what happens is there'll be a very dense network of tissue here that will be called as stratum lucidum. This is not from a skin of a palm and sole. I'll show you pictures of stratum lucidum for sure. The ideal thing is I have stratum basal or the germinatum, stratum spinosum, a lot of them, and the other keratohyalin granules. You can see the brown granules, right? Keratohyalin granules. This granules will also be there in your hair follicle, but in hair follicle it will look different in color. They'll look reddish in color, right? Here it's bluish in color, the keratohyalin granules. Maybe I'll go to an area where I have a little bit of more prominent granular layer. I don't have a much of a prominent granular layer in this biopsy, but yes, granular layer will be like 1 or 2 layers thick all over, fine. Yeah, maybe this place I do have a little bit of good amount of granularity, right? The bluish granules here is called as keratohalin granules. So what is the function of this? Because as a pathologist, I want you guys to know everything normal. So once I know normal, abnormality becomes a little bit easier, right? So what keratohalin granules does is it gives the nutrition to the topmost layer, because topmost layer where you can see like a weave, like sieve like thing, right? That's your stratum corneum or the corneal layer, right? This corneal layer is anucleate. It has nothing but proteins. So what it does is when a cell from spinosum moves down to the granulosum, it kind of condenses all the protein, and when it goes to the corneum, it kind of releases all the protein. It becomes flakes of keratin, right? So these blue things in keratohalin granules are nothing but proteins. I do have lots of proteins which are more theoretical, might not be helpful for me for the diagnosis, right? When it comes to stratum corneum, like I said, stratum corneum has two different appearances. In the skin of palms and soles, I'll have a layer, a very pinkish layer between the stratum corneum and the stratum granulosum, right? Very pink layer called as stratum lucidum. Supposed to be clear, but yeah, it will be pink in color on a microscopy, a stratum lucidum. That will not be seen in any other condition, any other body parts, on the skin of your palms and soles. The reason being, it's nothing. It's very simple to understand. See, this is a very beautiful keratin, right? It's like a fluffy keratin. If I have more of friction, more and more of friction, what happens is the lowermost part here becomes condensed. That's all. That's what is called a stratum lucidum. Nothing, just condensed keratohalin granules. So it's condensed stratum corneum there, fine. So what happens here is, if I have a disease where I'm gonna chronically keep on itching, chronically keep on scratching the skin, chronic scratching of the skin can result in a pathological condensation of the stratum lucidum in even in non-sole, non-palm parts. Fine. So that is what happens to stratum lucidum when it's going to be there in a pathological condition. But in normal physiological condition, both in the palms and soles, you'll have a very condensed layer. You'll have a thick condensed layer. Like I said, I'll put you the picture of it, right? So this is simple stratum corneum. Corneum is anucleate. You know that for a very long time, right? It's completely anucleate cell. When you have nucleus, we call that parakeratosis and have multiple outcomes of that. Fine. We'll see it when you go to the individual disease process of dermatopathology. Fine. Now, I just want to add one more thing. There's one more cell as well, which I feel a postgraduate should know. When you go and scan through the stratum spinosum, okay, this is going to be seen as stratum spinosum only. Maybe we'll zoom it out a little bit so that I can search for the skin. Yeah. And we need to search for that guy. It'll be seen, but not that easily. It's not that rare as well. If you look at this is stratum spinosum. Who's this guy? Melanocyte, right? Who's this guy again? Perfect melanocyte, right? So you look at this. I have one more cell in the stratum spinosum, which also has the retraction artifact, which also has the halo around the nucleus, right? This nucleus, if you look, it's exactly a little bit of compressed. It looks like a bean shape. This bean-shaped nuclei is called as your Langerhans cell or the dendritic cell. It's so beautifully organized. This may be a corneum, right? So any bacteria is going to come via this layer only. So corneum, it immediately comes to my Langerhans cells. My Langerhans cells will pick up the bacteria, and with the dendritic network, Langerhans cells also have dendritic network, right? With the dendritic network, it goes to my dermis. In dermis, you have these capillaries, the tiny capillaries. It goes there, presents to the lymphocytes, and then it will start reacting, right? So these halo cells in the stratum spinosum are nothing but your Langerhans cells, right? So Langerhans cells, your giant cell, Langerhans is your dendritic macrophages, right? You will see them quite often. Look at this. I have can see clearly a halo, a compressed kind of a bean-like appearance. That's your Langerhans cells. Look at the beauty of the melanocytes in the basal layer here. It's like a cap, right? It's like just on the top to protect from this your sun-induced UV-induced mutation, right? That's why melanin is always good. Melanin is always protective. That's one of the reasons that there's no protection in a Caucasian. There's more of skin pigmented lesion in a Caucasian compared to our Indian population, right? Okay. So that's just about the epidermis. This is a trial run for me to see how well it works. If it works good for you, I don't have a pointer for now. Maybe in future I'll try to incorporate some pointers so that I can point exactly what they are. Fine. So do put in your comments how it is, and let's learn more and more things together. See you then. Till then, bye bye from Dr. Ranjit. Bye bye.